In section 9 of chapter 1, we're going to be solving systems of equations utilizing my favorite technique, the elimination technique. The reason the elimination technique is my favorite is it typically, but not always, it typically eliminates fractions as being an issue. Downside, you typically have slightly larger numbers. First, I got a system for you. It's 3x plus 2y equals 8, and x minus 2y equals negative 16. Before I explain the elimination technique, I want to explain where it comes from. It's technically still a variation of the transitive property of equality, but I want to take it a step further. When dealing with the blue equation, I could easily just add 7 to both sides. It's not going to accomplish anything, but mathematically I can do it, because I'm adding the same thing to both sides. I could also add a 7x to both sides. Again, it won't accomplish anything. It won't get me in the direction I want to go. But mathematically, I'm not breaking any rules because I'm adding the same quantity to both sides. Additionally, another thing I could do, which would be really weird if I did it this way, is I could add a 1/2 to the left side and add a 0.5 to the right side. Because again, they're the same thing. Transitive property of equality. Here's what I'm going to do, though. For this equation on the left, the x minus 2y, what I'm going to do is I'm going to add this equation to it. So you can kind of think about it as adding the left sides of the equal sign to each other. And instead of adding to the right side, instead of adding a 3x plus 2y, I'm going to add something it's equal to. I'm going to add the 8. So we add the left sides together and the right sides together because they're equal. And something magical will happen. Also do keep in mind, when we give names to techniques or ideas or formula, we don't just pick random words. We actually mean what they say. This technique is called the elimination method because when I add 3x plus x, we get 4x. When you add a 2y and a negative 2y, they eliminate. Hence why this is called the elimination technique. And that would be equal to 8 plus negative 16 is negative 8. So now through the addition of those two equations to each other, I now have a new equation that only has a single variable in it. I have 4x equals negative 8. That means I can solve for x. I can divide both sides by 4. Leaving me with x equals negative 2. I just now discovered the value of x. To find the value of y, I take that negative 2 and plug it into either the blue equation or the red one. It does not matter. I'm going to plug it into the blue one because it's got smaller numbers. So instead of x, I'm going to put a negative 2 minus 2y equals negative 16. I'm going to add the 2 to the other side and get negative 2. Why did I do that in purple? Negative 2y is equal to negative 14. Get rid of the negative 2 in front of the y by dividing both sides by negative 2. And that will give us y is equal to 7. If you stop here and say, I'm done, I got my answers, you are wrong. We are finding a coordinate. You need to write this as a coordinate. The answer is negative 2 comma 7. Now this one wasn't too bad because it was actually set up for elimination. We didn't need to do much. My next example will not be set up for elimination. We need to set it up ourselves before we go through this process. This system actually has two issues. One of which is if we just straight up add them, neither the x's or the y's would cancel. But the bigger issue, at least a more immediate issue, is they're not in standard form. When doing elimination, we like it to be the x, then the y equals the constant. The red equation is not written like that. I need to move that negative 8x to the other side of the equal sign. So I'm going to add 8x to the other side. That's going to allow me to get a new system. 8x plus 3y equals negative 5, and 2x minus 5y equals 16. All right, now they're both in standard form. Now we can go through the elimination process. In order for elimination to work, the coefficients in front of one of the variables, either the x's or the y's, doesn't matter which, need to be opposites. I need something like a 2x and a negative 2x, or a 6y and a negative 6y, or a 13x and a negative 13x. So since that doesn't happen here, I'm going to have to force it to happen. I'm going to change the y's. The 3 and the 5 can both turn into 15s as long as I take the first equation and multiply everything by 5, and as I take the second equation and multiply everything by 3. When I do that, I will get a 40x, so notice how numbers tend to get bigger with elimination, plus 15y equals negative 25. And then for my blue equation, I have a 6x minus 15y is equal to 16 times 3 is 15, 45, 48. And now I have a positive 15y and a negative 15y, meaning I can add them together and the y's will eliminate. When you add them together, you're going to get a 46x is equal to 25, negative 25 and 48. What does that make? 23? So I have the equation 46x equals 23. Divide both sides by 46, leaving me with x is equal to 1/2. I can substitute that 1/2 into any equation that I have that has an x and a y in it. Does not matter which. I'm going to pick the red equation from the original. So that's going to give me 3y equals negative 8 times 1/2 minus 5. That leaves me with 3y equals negative 8 times positive 1/2 is negative 4. Negative 4 minus 5 is negative 9. Divide both sides by 3. Y is going to equal negative 3. There's my y value, which means my answer is positive 1/2 comma negative 3. That is the location where these two lines intersect.